We will see 5W and 1H for predictive maintenance in IBM Maximo. What is predictive maintenance? Why predictive maintenance? Who is involved in predictive maintenance? When this predictive maintenance is to be performed, where and how? So, what is predictive maintenance? It is to identify potential failures before breakdowns, predict asset conditions using analytics tools, monitor performance data with IoT sensors, automate maintenance scheduling for reliability, and use AI to detect anomalies early, focus on critical operational equipment needs, leverage insights for better decision making, replace components before complete failure occurs, align tasks with business operational goals, integrate processes with Maximo workflows. Why predictive maintenance minimizes downtime through proactive interventions, reduce costs of unexpected asset repairs, extend the life cycle of critical equipment, improve reliability with consistent performance monitoring, enhance safety by preventing catastrophic failures, optimize resource allocation for maintenance activities, boost efficiency in operational asset management, ensure compliance with regulatory maintenance requirements, increase productivity with uninterrupted workflows, support sustainability through energy efficient operations. Who all are involved in predictive maintenance? Maintenance teams perform scheduled predictive tasks, asset managers oversee strategies and decisions, data analysts interpret performance condition trends, IoT specialists configure sensor based monitoring systems, AI experts develop anomaly detecting algorithms, field technicians execute identified repair tasks, operation managers prioritize maintenance within workflows, compliance officers ensure regulatory task adherence, IT teams manage Maximo integration systems, stakeholders evaluate predictive maintenance effectiveness periodically. Then comes when to perform this regular monitoring equipment during operational hours, immediate address anomalies detected in data, before seasonal changes affecting operational conditions, after reaching predefined performance thresholds limits, periodically as defined in maintenance schedules during high demand periods to ensure reliability, after integrating new IoT sensor systems, post installation of critical replacement components when operational data suggests performance issues as advised by AI generated maintenance alerts, where apply to manufacturing production line assets, monitored within utility plans for efficiency, integrated with transport fleets for tracking, implemented in hospitals for equipment safety, used in data centers for cooling systems, installed in oil rigs for drilling tools, applied to warehouses for automated systems, in mining facilities for excavation machinery, in airports for baggage handling equipments, across multi site operations for asset consistency. And then comes how: collect real time data using IoT devices, analyze performance metrics with Maximo analytics tools, create predictive models using historical asset data, generate alerts for detected performance deviations, automate work orders for repair scheduling, monitor health using dashboards and reporting tools, perform inspections based on sensor analytics, use AI algorithms for predictive insights generation, integrate third party systems for additional data sources, evaluate results to optimize maintenance processes.